In this session here, we're going to take a look at subtracting, and in particular, subtracting when you're using or including some negative numbers. So I'm going to go ahead and choose a simple problem to start with. We've got 3 minus 5. Now to solve this problem, we can use the illustration from the previous session about using particles and antiparticles. However, what we have going on here is we do not have a positive number with a negative number. We actually have two positive numbers here. This symbol here, this subtraction symbol, is not telling us that this 5 is a negative 5. It's simply telling us that we're subtracting. And you have to remember that if the sign is missing before a number, that is the same thing as that number being a positive. So we could rewrite this really as positive 3 minus a positive 5. These two statements say the same thing. 3 minus 5 is the same thing as a plus 3 minus a plus 5. Well, let's see now if we can do this or solve this straightforward by using our particle-antiparticle illustration from before. Our positive 3 is going to be represented by the three particles, the three circles. But over here, we also have a positive number, 5. How can you take 5 particles away from 3? At first here, it looks like we're kind of stumped. But we can actually make use of a little trick to actually solve this problem through antiparticles and particles together. You need to remember back to several sessions, several lessons ago, about the characteristics of the number 0. One of the characteristics about the number 0 is that if you add 0 to a number, doesn't matter what that number is, the value of adding 0 to that number is going to leave you with that number. It's not going to change that number at all. So if we started off with 17 and we add 0 to 17, 17 plus 0 is still 17, which is the number that we'd started with. If we chose 101 to start with and we added 0 to it, 101 plus 0 is 101. We haven't changed anything by adding 0 to it. So what we're going to do over here is use a little trick. And what we're going to actually do to these three particles is we're going to add 0 to it. But we're going to add 0 to it in a particular method. And by the method we're going to make use of is by adding 2 particles and 2 antiparticles together. Well, if you remember, what happens when these 2 particles and these 2 antiparticles combine? Well, they destroy each other. They cancel each other out. Well, when they cancel each other out, that's the same thing as 0. So by adding to these 3 here, 2 particles with 2 antiparticles, in essence, what we've really added is 0. Now, what we have all together are 5 particles and 2 antiparticles. Now, let's go up here and subtract, take away the 5 particles. There's the first, the second, the third, the fourth, and the fifth. What are we left with after we have subtracted out those 5 particles? What we're left with are 2 antiparticles. And as far as the number goes, what do those 2 antiparticles represent? They represent the number minus 2. So we can see that 3 minus 5 is in fact minus 2. Now, even though this method, this illustration of particle-antiparticle has helped us solve the problem, it is a little bit confusing and cumbersome to deal with. Having to remember to add 0 through a trick of adding an equal number of particles with antiparticles is not necessarily the best method to try to deal with subtracting a bigger positive from a smaller positive. So what mathematicians have discovered is that to every subtraction problem, there is also an addition problem that will yield the same answer. And the way you do that is by converting the subtraction problem to an addition problem and then changing the number that's after the subtraction sign to its opposite. Well, what do I mean by that? Well, let's take the same example here of 3 minus 5. Now, this is a subtraction problem. This is really a positive 3 minus a positive 5. we can rewrite this problem. And I'm going to go to blue now to indicate that we've made the change here. I'm going to rewrite this as an addition problem. And the way you rewrite a subtraction problem as an equivalent addition problem is you take the number to the left of the subtraction symbol and you leave it alone. So I'm going to keep that as a 3. Then you change your subtraction symbol to a plus. Then the final thing you do is you take this number here and you change it to its opposite. Well, what's this number? This number's 5, or positive 5. Well, what's the opposite of positive 5? Well, the opposite of positive 5 is negative 5. So 3 minus 5 is really the same thing as 3 plus a negative 5. Well, how has that helped us? Well, as far as the illustration goes of particles, antiparticles, it's actually helped us, I think, quite a bit. Because what we're doing now is we're simply adding. We're not having to come up with this little trick of adding 0. So let's go ahead and do this through the illustration. We have 3 particles. That's a positive 3. That gives us 3 particles. What we're doing is we're adding to it 5 antiparticles. So I'm going to go here and add the 5 antiparticles to it. Okay, what happens to these 3 particles when they interact with those 3 antiparticles? They cancel each other out. So after these have canceled each other out, what are we now left with? We're left with 2 antiparticles, which is the same thing as minus 2. These 2 antiparticles are the same 2 that we were left with up here. It's just here, in this second example, we changed our subtraction problem to an equivalent addition problem. Okay, on this screen here, I just want to give some quick examples of subtraction problems, and I want you, in your own mind as you are listening to this and viewing it, to try to determine what the answer is yourself. Our first problem, 1 minus 3. I want us to change that into an addition problem that has the same answer, into an equivalent one. The way you do it is you take the number to the left of the subtraction sign and you keep it the same. You change your subtraction to an addition. Then what you do is you take this number and find the opposite of it. Well, what's the opposite of 3? The opposite of 3 is negative 3. So 1 minus 3 is now rewritten as an addition problem as 1 plus a minus 3. And the answer there will be negative 2. Next, 7 minus 10. Let's rewrite that as an addition problem. Well, you take the number to the left of the subtraction symbol, which is a 7, and you rewrite it. You change your subtraction to an addition. And then you take your second number here and you take the opposite of it. Well, what's the opposite of 10? A positive 10. Well, the opposite of 10 is a negative 10. So 7 minus 10, this subtraction problem has been rewritten as an addition problem as 7 plus a minus 10. And what's that equal? That equals a negative 3. What about 5 minus 6? Okay, take your number to the left of the subtraction and rewrite it. That's going to be our number 5. You change your subtraction symbol to a plus or an addition symbol. And then you change your second number here by changing it to its opposite. Well, what's the opposite of 6? The opposite of 6 is negative 6. What's 5 plus a minus 6? Well, that's going to be a minus 1. Let's take a look at the last example. Let's say we're starting off with a negative number, and then we're going to subtract a positive number from it. Well, let's go ahead and rewrite this as an addition problem. What's the number that's to the left of this subtraction sign? This. Now don't confuse it. This subtraction sign, or this negative symbol before our first number, is not telling us to subtract 4. When it's the very first number in a problem and you have a minus sign before it, it's telling you that that's a negative number. It's not telling you to subtract. So this is actually a negative 4. So we're going to rewrite our negative 4. And now we come to our subtraction sign. We're going to change it to a plus. Then we're going to change this number here to its opposite. What's the opposite of 2? The opposite of 2 is negative 2. So minus 4, negative 4 minus 2 is the same thing as negative 4 plus a negative 2. Well, what is a negative 4 plus a negative 2? Well, if you were to add 4 antiparticles here and add to it 2 more antiparticles, you would have 6 antiparticles altogether. Your answer would then be -6. Which then takes us to our review page. For every subtraction, there is an equivalent addition problem that will yield the same answer. So for every subtraction problem, there is an equivalent addition problem that will give you the same answer. Also, it's sometimes easier to solve a subtraction problem by changing it into an addition problem. And lastly, subtracting a number yields the same result as adding that number's opposite. That finishes up session 20 on subtraction.